Baik, di sini ada video garment color fastness to washing and to rubbing. Simak videonya.
It is changed, or other items in the washing load or other parts of the garment are stained by the unfixed color. Color fastness is defined as the resistance of a material to change in any of its color characteristics, to transfer of its colorant to adjacent materials, or both, as a result of the exposure of the material to any environment that might be encountered during the processing, testing, storage, or use of the material. The most used test for color fastness to washing is the AATCC test method 61, color fastness to laundering, home and commercial, accelerated. This test was devised for use on garments and fabrics that will require many launderings. Within the test are 5 different test procedures to cover the wide range of product care used by consumers. These scenarios make use of detergent and various levels of abrasive action in the laundering, both with and without chlorine in the bath. A laboratory machine, launderometer, is the instrument used. A single 45-minute cycle in the launderometer with these procedures will approximate 5 hand or home laundering cycles. However, the evaluation of staining effects that replicate 5 launderings cannot always be achieved in the 45-minute test. This is because unfixed dye on the fabric that moves into the laundering bath can vary tremendously from one shade to another, thereby reducing the predictability of the 45-minute test. As a result, the specimens are tested under controlled conditions of temperature, the type of detergent, the detergent solution strength, abrasive action, and if needed, bleaching chemistry to make the predictability as reliable as possible. The launderometer has a carriage that holds closed stainless steel canisters in which the specimens and laundering solution are placed. The carriage turns through a heating bath, and this action results in tumbling of the specimen with the laundering solution and stainless steel balls. For the basic procedure, the laundering solution uses a standard reference detergent from AATCC and contains no fluorescent whitening agent or phosphate. The frictional characteristics of the wet sample with the stainless steel balls and the inside of the canister accelerates the laundering effect. Also, the amount of laundry solution with respect to the weight of the sample results in a low liquid ratio and, as a result, more abrasion. There are 5 staining tests. They differ by the percentage of detergent used, whether or not chlorine bleach is used, the number of steel or rubber balls, and the temperature. Staining tests 1A, 2A, and 3A do not use any bleach. Procedures 4A and 5A use bleach. For evaluation of staining, use a multi-fiber strip for tests 1A and 2A. For test 3A, either a multi-fiber strip or a bleached cotton test fabric is used. Staining is not determined for tests 4A and 5A. When the multi-fiber strip is used, it is attached to one side of the specimen. Only one specimen is tested per canister. This table gives the test conditions for each test. Test 1A is used to evaluate the color fastness of textiles that are expected to withstand repeated hand launderings at low temperature. Specimens subjected to this test should show color change similar to that produced by 5 typical hand launderings at a temperature of 40 degrees Celsius plus or minus 3 degrees, 105 degrees Fahrenheit plus or minus 5 degrees. Test 1A is modified to be Test 1B for evaluating the color fastness of textiles that are expected to withstand repeated hand laundering at cool temperatures. Specimens subjected to this test should show color change similar to that produced by 5 typical careful hand launderings at a temperature of 27 degrees Celsius plus or minus 3 degrees, 80 degrees Fahrenheit plus or minus 5 degrees. Test 2A is designed to evaluate the color fastness to washing of textiles that are expected to withstand repeated low-temperature machine laundering in the home. Specimens subjected to this test should show color change similar to that produced by 5 home machine launderings at medium or warm setting in the temperature range of 38 degrees Celsius plus or minus 3 degrees, 100 degrees Fahrenheit plus or minus 5 degrees. Test 3A is for Washing of textiles considered washable under vigorous conditions. Specimens subjected to this test should show color change similar to that produced by 5 home machine launderings at 60 degrees Celsius plus or minus 3 degrees, 140 degrees Fahrenheit plus or minus 5 degrees, without chlorine. Test 4A allows for the evaluation of color fastness to washing in the presence of available chlorine. Specimens subjected to this test show color change similar to that produced by 5 home machine launderings at 63 degrees Celsius plus or minus 3 degrees, 145 degrees Fahrenheit plus or minus 5 degrees, with 3.74 gallons per liter, 0.50 ounces per gallon of 5% available chlorine per 3.6 kilograms, 8.0 pound load. Test 5A concerns the evaluation of the color fastness to washing of textiles that may be laundered in the presence of available chlorine. Specimens subjected to this test should show color change similar to that produced by 5 home machine launderings at 49 degrees Celsius plus or minus 3 degrees, 120 degrees Fahrenheit plus or minus 5 degrees, with 200 plus or minus 1 parts per million available chlorine. After the launderometer procedure is run, the canisters are removed from the machine. It is removed and the contents are poured into a handheld strainer. The test specimen and stainless steel balls are captured in the strainer. The specimen is then squeezed by hand to remove as much of the laundering solution as possible. The specimen is then put into a beaker that contains distilled water that was pre-measured. The specimen is stirred in the rinsed water for a specified time, and the beaker is poured into the strainer. Water and vegetation. The specimen with the multi-fiber strip is again strained and extracted. Color change is evaluated using AATCC Evaluation Procedure 1, Grayscale for color change. For improved precision and accuracy, the specimen should be rated by more than one rater. A rating of grade 5 would indicate a negligible or no change in the shade of the specimen. At the other end of the color change scale, a grade 1 rating would show severe color loss as defined by the Grayscale Step 1. The color change can be quantitatively assessed by measuring the color difference between the unwashed sample and a test specimen and using a suitable colorimeter or spectrophotometer with the appropriate software. This procedure can be found in the AATCC Evaluation Procedure 7, Instrumental Assessment of the Change in Color of a Test Specimen. Staining can be evaluated as directed in AATCC Evaluation Procedure 2, Grayscale for staining, or in AATCC Evaluation Procedure 8, Chromatic Transference Scale. Whichever scale used should be indicated when recording the test results. Here, a grade 5 shows negligible or no color transfer, and a grade 1 shows significant change. Full disclosure of these rating systems can be found in the Rating Procedures subsection of the CD. Crocking is defined as a transfer of colorant from the surface of a colored yarn or fabric to another surface or to an adjacent area of the same fabric, principally by rubbing. The AATCC Test Method 8, Crock Meter Method, is used throughout the world to measure the propensity of a sample to crock. A standardized machine called the Crock Meter is used. The crocking test method is designed to rate the amount of color transferred from the surface of a colored textile material to another surface by rubbing. All fibers in the form of yarn or fabric can be tested. Dyed, printed, or otherwise colored materials can be tested. It is not recommended for use on carpets or prints, where the pattern area is too small to use this method. White test cloth squares are used in the crocking test as the abrasion surface for both wet and dry conditions. If the specimens have been washed, dry cleaned, be shrunk, ironed, finished, or experienced some other processing, the color transfer from the material may be affected. The test may be made before, after, or before and after such treatment. In the test, a colored test specimen is rubbed with a white crock test cloth under controlled conditions. The amount of color transferred to the white test cloth is graded by comparison with the grayscale for staining, or the chromatic transference scale, and a grade is assigned. In this particular dry crocking test, a black specimen is placed on the base of the crock meter, resting flat, with its long dimension in the direction of rubbing. The specimen holder is placed flat over the specimen as an added means to prevent slippage. A standardized white test cloth square is then mounted on the tip of the round peg, with its weave parallel with the direction of rubbing. The test cloth is held tight and in place to the peg via a special spiral wire clip. The covered peg is lowered into the test specimen. Beginning with the peg positioned at the front end of the sample, the covered peg is pulled across the surface of the specimen for 10 complete turns at a rate of 1 turn per second to yield 20 movements across the surface of the test specimen. After the test is run, remove any extraneous fibrous material from the test cloth square before evaluating. Also, the test cloth is observed as to whether the test was properly executed. If dyed yarns are to be evaluated, it is preferred to knit a piece of fabric to perform the test. If the knitting machine is not available, then wind the yarn tightly on a suitable form. Wet crocking uses the same procedure as the dry test, but with a wet crocking square. The technique for preparing wet crock cloth squares is very important. A conditioned crock square is thoroughly wet out with a pre-measured amount of distilled water based on the dry weight of the square. The water is pipetted onto square 1, and the square is manipulated with tweezers to make sure the water is evenly absorbed. Only one sample is prepared at a time. The crocking test is run according to test procedure with 10 cycles, resulting in 20 rubbings. For rubbing, according to this protocol, then the crock square is air dried and conditioned before evaluating. The specimen, after wet and dry crocking, should be examined for loose fiber on the surface. Napped, brushed, or sanded materials often have loose fibrous material on the surface, which can interfere with the rating. Therefore, the extraneous fibrous material should be removed by pressing lightly on the crock circle with the sticky side of cellophane tape before evaluating. The amount of color transferred from the specimen to the white test square is examined by means of the AATCC Evaluation Procedure Aid 9-step chromatic transference scale. The crocking test square should be rated as to staining, and the reporting should state whether dry or wet crocking, the grade, and the test method used. See the subsection on procedures in the care and appearance section of the CD for more information.
Kemudian ada slide selanjutnya tentang video. Kemudian ada video tentang determination of color fatness against artificial light.
Hi friends, color fastness against light is the color resistance of all kinds of textile materials with artificial light representing daylight. For this test, we use the color fastness against the light device that has a xenon arc lamp, a filter system with 7 units of 1R, filter to filter light, standard thermometer, a sample holder, an opaque cardboard for preparing the sample, a mask, and some blue standard reference form of 1 each point. The sample is laid out on a smooth space. A sample of 1 centimeter by 4.5 centimeters is cut. The sample is properly marked. If our sample is made of yarn, it is rolled out horizontally on an opaque cardboard. If the material is fiber, it is rolled in a bundle form and punched to the opaque cardboard. If the material is printed fabric, the samples are taken from each of the different samples. This method, more than one sample are tested together. There are 5 types of methods, but the method by which more than one sample are tested is the method number 2. Placing the prepared sample into the holder apparatus, we cover a specific part of it with a mask. As you can see here, the place exposed to the light remains uncovered. To prepare a standard for the sample, firstly, cut a sample of 1 centimeter and 4.5 centimeters from the reference 1. We make sure that the side here and the side of the prepared sample are the same. Their being the same size will facilitate the evaluation process. We cut the drawn sample along a straight line. Punch the first wall reference that we have prepared at the initial point. We punch our blue scale numbers 1 to 8, which are prepared in this way, onto the opaque cardboard with the same ones in the same size. In the method number 2, we have the opportunity to test more than one sample at the same time, and the section that has been exposed to light with a mask is left uncovered. The prepared test samples are placed into the device. The sample that has been prepared assesses color fastness against light in our device. The filter system to assess color fastness against light comprises of 7 1R filters and a heat filter as a glass cylinder. We place the reference sample we put in the sample holder earlier in the device too. We place our device in the space. Method which we have explained. We have the opportunity to test more than one sample. We check out the parameters that we set. For this, make sure that the temperature does not exceed 50 degrees Celsius, that humidity is 40%. We take the energy to be at 42 for the best control filter. The start button is pressed after setting the total time period. Tolerances are checked and the test is started by pressing the start button. Whether the humidity is 40% or not is checked by a red moisture control light. The test is ended when 4 equal discolorations occur according to the 4 blue wall scale up on the customer's demand. When setting the time period, it is expected that each of the blue scales will fade in a period twice more than the previous one. Terminated when a fading that is equal to number 4 on the grey scale occurs on the reference blue wall number 6. In the test, the specimen exposed to light over the same period of time. No difference between the section covered with a mask light are compared with the blue scale. 1 means the worst, and 8 means the best result on the blue scale. Interval values such as 5 and 6 can also be given.